So this bar graph here tells us bubbles blown by each gum chewer. We have 4 different gum chewers, and they tell us how many bubbles each of them blew. So what I want to do is I want to figure out first the mean of the number of bubbles blown, and then also figure out how dispersed is the data. How much do these vary from the mean? And I'm going to do that by calculating the mean absolute deviation. So pause this video now. Try to calculate the mean of the number of bubbles blown, and then after you do that, see if you can calculate the mean absolute deviation. All right, so step 1, let's figure out the mean. So the mean is just going to be the sum of the number of bubbles blown divided by the number of data points. So Manuela blew 4 bubbles, so she blew 4 bubbles. Sophia blew 5 bubbles. Jada blew 6 bubbles. And Tara blew 1 bubble. And we have 1, 2, 3, 4 data points. So let's divide by 4. And so this is going to be equal to 4 plus 5 is 9, plus 6 is 15, plus 1 is 16. So it's equal to 16 over 4, which is 16 divided by 4 is equal to 4. So the mean number of bubbles blown is 4. And I can do that. Let me actually do this with a bold line right over here. This is the mean number of bubbles blown. So now what I want to do is I want to figure out the mean absolute deviation. I'll do it right over here, mean absolute deviation. And what we want to do is we want to take the mean of how much do each of these data points deviate from the mean. And I know I just used the word mean and twice in a sentence, so it might be a little confusing, but as we work through it, hopefully it'll make a little bit of sense. So how much does Manuela's, the number of bubbles she blew, how much does that deviate from the mean? Well, Manuela actually blew 4 bubbles, and 4 is the mean. So her deviation, her absolute deviation from the mean is 0. How much did, and actually let me just write this over here. So absolute deviation, that's AD. Absolute deviation from the mean, Manuela didn't deviate at all from the mean. Now let's think about Sophia. Sophia deviates by 1 from the mean. We see that right there. She's 1 above. Now, we would say 1 whether it's 1 above or below because we're saying absolute deviation. So Sophia deviates by 1. Her absolute deviation is 1. And then we have Jada. How much does she deviate from the mean? We see it right over here. She deviates by 2. She is 2 more than the mean. And then how much does Tara deviate from the mean? She is at 1, so that is 3 below the mean. That is 3 below the mean. So once again, this was 2, this is 3. So she deviates, her absolute deviation is 3. And then we want to take the mean of the absolute deviations. That's the M in MAD, in mean absolute deviation. This is Manuela's absolute deviation, Sophia's absolute deviation, Jada's absolute deviation, Tara's absolute deviation. We want the mean of those, so we divide by the number of data points. And we get 0 plus 1 plus 2 plus 3 is 6 over 4. 6 over 4, which is the same thing as 1.5, or let me just write it in all the different ways. We could write it as 3 halves, or 1.5, or 1.5, which gives us a measure of how much do these data points vary from the mean of 4. Now, I know what some of you are thinking. Wait, I thought there was a formula associated with the mean absolute deviation. It seems really complex. It has all of these absolute value signs and whatever else. Well, that's all we did. That was just when we write all those absolute value signs, that's just a fancy way of looking at each data point and thinking about, well, how much does it deviate from the mean, whether it's above or below? That's what the absolute value does. It doesn't matter if it's 3 below, we just say 3. If it's 2 above, we just say 2. We don't put a positive or negative on it. But just so you're comfortable seeing how this is the exact same thing you would have done with the formula, let's do it that way as well. So the mean absolute deviation is going to be equal to, well, we'll start with Manuela. How many bubbles did she blow? She blew 4. From that, you subtract the mean of 4. Take the absolute value. That's her absolute deviation. And of course, this does evaluate to this 0 here. Then you take the absolute value. Sophia blew 5 bubbles, and the mean is 4. Then you do that for Jada. Jada blew 6 bubbles. The mean is 4. And then you do it for Tara. Tara blew 1 bubble, and the mean is 4. And then you divide it by the number of data points you have. And let me make it very clear. This right over here, this 4 is the mean. This 4 is the mean. So you're taking each of the data points and you're seeing how far it is away from the mean. You're taking the absolute value because you just want to figure out the absolute distance. Now you see, or maybe you see, 4 minus 4, this is, let me just in a different color. 4 minus 4, that is the 0. That is that 0 right over there. 5 minus 4, absolute value of that, well, that's going to be, let me just in a new color. This is just going to be 1. This thing is the same thing as that over there, and we were able to see that just by inspecting this graph or this chart. And then 6 minus 4, absolute value of that, that's just going to be 2. That 2 is that 2 right over here, which is the same thing as this 2 right over there. And then finally, our 1 minus 4, that's negative 3, but the absolute value of that is just positive 3, which is this positive 3 right over there, which is the distance. This distance right over here, you divide it by 4, you get 1.5 again. So hopefully you found this mean absolute deviation example as interesting as I did.